Hello viewers, my name is Jungo David. I welcome you for this lesson. In this lesson, we are looking at the details of the organic chemicals of life, and we are looking at part 1 of the organic chemicals of life. Part 1 of the organic chemicals of life, and this part 1, we are looking at carbohydrates and lipids. Since there are two, we are going to first look at carbohydrates alone, then later we shall look at lipids. So we are going to look at carbohydrates first. We are going to look at carbohydrates first. But as we are looking at carbohydrates, you should have it in mind that by the end of the whole concept of carbohydrates and lipids, you should be able to compare. You should be able to compare carbohydrates and lipids. And what will you compare? Their composition, their chemical composition, their structures, then advantages, and functions. Can compare their functions, even properties, functions, then advantages and disadvantages, and over each other for the same functions they perform. For the same functions they perform. For example, you find that both are used for storage of food. Which advantage does a carbohydrate has over the lipid, or lipid over carbohydrate? Then you can also find them as sources of energy sources. Both can be used as respiratory substrates. But which advantage does this has over this, or this over this? So such content is going to be very important here, and you'll find that in most cases they will examine both carbohydrates and lipids. You always find questions requiring you to have understood this comparative study between carbohydrates and lipids. So I wanted you to have it in mind from the start. So it means that we are going to first understand the content of carbohydrates. Then after that, you understand the content of lipids, and we shall come back to see whether we are able to compare or to have this comparative study. And that one will require you to have understood the details of carbohydrates and lipids. So we are going to first look at carbohydrates, and under carbohydrates, we are going to give more attention to the following. Under carbohydrates, we are going to give attention to the following. 1, which content are we going to look at here? The content here, we are going to look at the composition. The composition. What are the carbohydrates composed of? That is chemical composition. That is chemical composition. Then we shall look at their general formula. We shall look at their general structure. Then we shall look at their classification. Classification of carbohydrates. And then we shall also look at the structure of each class. Or for each class, we shall look at the structure. For each class, Let me summarize it like this. For each class, we shall look at its structure. We shall look at its properties. Now, before the properties, we shall see how it is synthesized. Synthesis and breakdown. Synthesis and breakdown. Then we shall look at its properties. Its properties. Its properties. And then functions. Functions. Then we can also compare the classes. Comparison of the classes. Comparison of the classes, and we shall also compare composition, just as you are seeing here. We shall compare the structures. We shall compare the structures. We shall compare their properties. We shall compare their functions, and we shall look at their advantages and disadvantages for those that perform the same what? Functions. For those that perform the same function. For those that perform the same functions. The same functions. So this information is really important for you to understand. Chemical composition, general formula, general structure, classification. For each class, we are going to see the different classes, and don't forget this information as required. So now we are going to start with the chemical composition. Let me note here what we are going to look at. In this introductory lesson, we are going to look at chemical composition. Maybe we can look at chemical composition, or we can look at also at general formula, general structure. Let me summarize them here so that we follow this order: general structure, then classification. Classification. So at least let's follow that order. Then details of each class. Details of each class. These are the details of each what? Class in number 5. Number 5. So now I can rub off this so that we understand the details. So now, chemical composition. The chemical composition of carbohydrates can easily be derived from here. If you look at, if I'm to separate this carbohydrates, carbo, that one is coming from carbon, and the hydrate is having two words. There is the word, there is hydrate and ate. Anything which has ate, it means that it contains oxygen. Contains oxygen. If you look at the sulfates, if you remember sulfates, they contain oxygen. Carbonates, they contain oxygen. So anything which contains oxygen ends with the word, any chemical compound which contains oxygen, most of them end with ate. So it means that it contains oxygen, then it contains hydrogen. This one can stand for what? Hydrogen. But that's not the meaning of the word hydrate. I just wanted to enable you to easily derive the elements that are there. So we are seeing that there is carbon, there is hydrogen, and there is what? Oxygen. So I just use this to enable you to derive the elements that are in carbohydrates. So you never find any other element in carbohydrates except these three. And every carbohydrate has all these three. So there is no any carbohydrate which has less, which has only carbon and hydrogen. I know you are aware of hydrocarbons. So every carbohydrate should have carbon, should have hydrogen, and should have oxygen. However, we are going to realize, okay, we can first note this, that chemical composition, carbohydrates are chemically made up of carbohydrates. All carbohydrates are chemically composed of carbon, hydrogen, and oxygen. Carbon, hydrogen, and what? Oxygen. Carbon, hydrogen, and what? Oxygen. So at least we have known the chemical what? Composition. Then their general formula is given as I've finished the composition. Now I'm on the general formula. Their general formula is like this. Is like that. That is their general formula, and in their general formula, we are still seeing that there is carbon. Let me simplify it for you here like this. Their general formula is like that. So you can see still in the general formula that the main elements are carbon, hydrogen, and oxygen. You can see that there is carbon, hydrogen, and what? Oxygen. But if you are to look at the different ratios, you'll find that the ratio of hydrogen to oxygen in any carbohydrate is always, the ratio of hydrogen to oxygen is always 2 to 1. Is always 2 to 1, just as in water. Just as in water. Just as in water. So that's the origin of the word hydrates. So it appears as if we are having carbon hydrated. Carbon hydrated. Hydrated. Hydrate. Anything, any compound which has hydrogen and oxygen in the ratio that is similar to water is called a hydrate. A hydrate. So the reason why these ones are called carbohydrates, because they have hydrogen and oxygen. They are compounds of carbon that have hydrogen and oxygen in the ratio of 2 to 1, just as in what? In water. So it appears as if we are having hydrated carbon. Just as you know that we have hydrated sodium carbonate. If you remember new chemistry, hydrated sodium carbon, where there is a hydrogen and oxygen, there is a portion of it having hydrogen and oxygen in the ratio of 2 to 1. So that's why they are called dehydrated. So we are going to see that except only one carbohydrate, the rest of the carbohydrates conform to this general formula. Where X and Y are variable, are different, which they are variable whole numbers, which may be the same or different, or what? Or different. I can illustrate this using a glucose. If you look at glucose, its molecular formula is C6H12O6. If I'm to express it in this form, if I'm to express it in that form, it is the same as expressed in that form. It is the same as C6H2O in brackets 6, in which case x is equal to 6 and also y is equal to what? To 6. If you can see this, if you can see that. So glucose is a carbohydrate because it is conforming to this general what? Formula. If I'm to use another example of sucrose, sucrose has a general formula of C12 H22O11. If you look at it, if I'm to express it in this form, it will be C12 H2O11, so that when I multiply 11 times 2, I get the 22, 11 times this one, in which case x is equal to 12 and y is equal to 11. So just as I said, that the values of x and y vary. In this case, x is 6. In this case, x is 12. In this case, y is 6. In this case, y is what? 12. So that's why they are variable and they are all whole numbers. They are whole numbers and they may be the same. For example, x and y, in this case, they are the same, and in this case, they are different or different. So that's what I was meaning. Even if I bring starch. Starch is made up of many glucose molecules, so you'll find that it is C6H10O5N. So that is it's made up of many glucose molecules, but with the loss of H2O. So with the loss of 2 hydrogen atoms and 1 oxygen atom during its formation. So this one can conform to the structure still by having C6N H2O5N, something like that. So in this case, x is equal to 6n and y is equal to 5n. So the truth is that at least most carbohydrates are able to conform to this structure, except only deoxyribose. So all carbohydrates conform to this general formula. All carbohydrates conform to this general formula. All carbohydrates conform to this general formula except deoxyribose. Deoxyribose is just 1 oxygen atom less than ribose, because ribose is like this, C5H10O5, that's ribose. But deoxyribose, for which it has C5H10O4. It is 1 oxygen atom less, that's why there is a deoxy. And this one is found in DNA, whereas this one is found in what? In RNA. So it is only the deoxyribose which does not conform to this general formula, because what we can see in each of these general formulae, each of these formulae is that the number of hydrogen atoms is twice the number of oxygen atoms. Maybe I can emphasize that in the lessons to follow.